Hello? Hi. Hey, good to have you back for another C++ session. My name is Tariq Madkour. I'll be talking to you about developing Metro-style applications using C++. I've been on the C++ team for about the past 11 years. I worked on different parts of the C++ toolset, starting with the IDE, doing interesting things like the build system and IntelliSense and trying to make that better. Then eventually moving to MS-Build, getting us to a whole new build system, and then working on some of the library stuff like implementing TR1 at the time. And then, lastly, working on some of the C++ 11 features that were put in VS 2010. But for the past 2 years, I've been working on this project that I couldn't talk to anybody about, and it actually feels great to finally be able to share this with all the C++ developers that really want to hear about it. So it's good to have you here. I'm very excited to finally be able to talk to you about how to leverage the Windows runtime and how to create Metro-style applications using C++. You already heard a number of sessions about it. And I'll before I go into the session, I want to explain to you where this session fits. Who went to Herb Sutter's session about using WinRT from C++? Raise your hand if you did. About half the people. Okay. Yes, it was. It was full pretty quick. Actually, since half of you weren't there, one of the first things I will do is actually recap, for the first maybe 5 or 7 minutes, the highlights of what you really, really need to know of that session in order to build on top of it for today. So Herb went through a preview, sort of an overview of the new language features that we added to Visual C++ to allow you to call into the Windows runtime. And what I will be doing in this session is tell you from our experience over the past year, after we created sort of the language features, we went to build applications, sample applications, on top of this new language syntax. And in our effort to do that, we saw some blocks that people would always hit, or some gotchas that they would always come and ask about. And I want to make sure that you are equipped with those up front, so when you're developing applications, you get to know about them and not have to spend a week or two actually finding out how to do this or how to do that. So it's sort of a complementary to Herb's talk. Dion also had a talk earlier today that went under the covers of how this stuff is actually implemented. So if you haven't watched that, make sure that you go watch it. It's going to be available online too. So with that said, let's go ahead. I'll start with just the 2 most important things that you need to know for this session. Number 1, what is the Windows runtime? Why do you care? Why is it relevant to you in C++ in Metro-style applications? And the second one is, what is this about the new language features that allow you to leverage the Windows runtime? So we'll spend some 5 to 7 minutes on that. Then I'll talk about some of the common patterns that are important while developing Metro-style applications using C++. So we'll talk a little bit about the type system, some of the intricacies of the type system, collections, iteration, how to do those. The async pattern is very important, so we'll spend some time on it. And then I'll briefly touch on calling into Win32. Ali Contenti had a talk about that yesterday, so if you didn't watch that, also please go watch it. What we really want you to get out of this talk is feel more comfortable developing those new language features. It takes time and practice to be proficient at it, so we want to give you some of those tips and tricks to get you ready and started. All right. So this is sort of a block diagram. If you were to say, okay, how is the Windows 8 APIs, how are they divided? This is a very, very high-level diagram. We've seen other diagrams in this throughout the conference. This is sort of a very high-level one. At the bottom, there is the core operating system services, the memory manager, and stuff that talks to the device drivers and hardware abstraction layers and stuff like that. But on top of that are the APIs that you can actually use. So for the longest time, we had this block on the right, which was the Win32 API. And it had a big set of API, thousands and thousands of APIs available to all applications targeting Win32. So in addition to those in Windows 8, we went and created, we went and expanded the Win32 APIs, and we went ahead and created what is called the Windows runtime. If you looked at the Win32 APIs, when they first started, it was flat C, all common, everything looked the same. Then as time evolved, started adding some C++ness into them, started creating some COM into them. COM was too complicated, so some people simplified a little bit of COM and did some sort of mini COM into them. So now you developing Win32 code, you have a wide variety of ways to consume Windows APIs. With WinRT, one of the goals was, okay, is there a coherent way that all new APIs can start? I mean, if we're going to start something new, let's at least start it with something that is that looks the same to everybody. So we standardized on something that is close to COM. If you're familiar with COM, you'll find that it's close to COM. And one of our goals was also, okay, let's not just make it available to C++. We want to make it available to everybody doing the .NET framework, everybody wanting to do JavaScript. So how can we create a runtime that exposes APIs that are homogeneous? They all have a common pattern to how to consume them, and they're consumable from multiple languages, right? So if you look at your Metro-style application, the APIs that are available to you are the ones in the box there. All the WinRT APIs that were created for Windows 8, as well as a subset of the Win32 APIs that make sense for Metro-style applications. As I mentioned earlier, Ale Contenti had a talk about this orange subset yesterday. So I'll touch very briefly on it at the end of the talk as well to just give you the gist of it. But if you want more details, you should go watch that talk. So again, it's all of Win32, all of WinRT, and some of Win32 actually makes sense to you. So to consume WinRT APIs, I mentioned earlier, sort of like COM, okay? Who's written COM code before? Majority, okay. COM is great, love COM. It's a very nice way for componentizing your app and having an ABI layer that can have a type-safe cross-module interactions. But if you looked at the code that you created for COM, it was a pretty nasty-looking C++ code. I mean, checking H results and no cascading. You can't do this, that. So we went and created some new language features to make it easier to consume APIs that are all of the WinRT type. And the most important thing, so this is sort of a sample of what that language looks like. If you went to Herb's talk, you understand what this looks like, but I'll give you just the gist of it. The most important thing to notice is that the hat there next to the UI animation variable. A hat is basically a pointer to a WinRT type. It is not a pointer, it's a reference. So the lifetime of that reference is managed by the Windows runtime. You actually explicitly say when it's created, and then from then on, it's ref counted. There's no garbage collection. This is not managed. This is all native. But it's basically a ref counted type, as opposed to a type that you allocate and delete yourself, right? The other thing to note is when you are newing one of those types, you use a reference new. So if there's anything that you want to know about how to consume WinRT APIs using that new language features, it's basically these two new things. There is a hat in front of every type, and if you want to create a new one of those, you use ref new instead of new. And that is all you need to consume types. There's a lot more that goes into the syntax to be able to produce WinRT components, but if all you're doing is consuming WinRT, so for now, all you need to do is this one. All you need to know about is this one. I also highlighted the namespaces there, and this is sort of an interesting thing that was a side benefit of it, is for a long time, Win32 was not namespace, was not organized into namespaces, and we thought, hey, we're creating a new set of APIs. We might as well actually make them modern and organize them into namespaces. The last thing is we added some new language syntax for things like delegates, which are essentially function pointers that you can take cross-module. All right, so that was the brief overview of what you need to know about that syntax, how to call a WinRT API, and how to pass types to it. So let's talk a little bit more about the type system. So we introduced some new types. With WinRT APIs, WinRT exposes a bunch of new APIs, and all of those have some common types that they use. Of course, no language addition would be complete without adding another string type, so that's exactly what we went ahead and did. So we created platform string. And don't laugh. There is actually a good reason to do a platform string. Think about what we're trying to achieve here, which is having a string that floats between multiple languages, works cross-module, and is ABI safe. And we basically had to create that one. WinRT had a string representation, and we wanted to create a very thin layer of representing that string in C++. We do not intend for that string to replace the standard strings. We really want you to use std_w_string, for example. We do not want you to use a different kind of string. Platform string is only there for when you're interacting with WinRT across a WinRT boundary. If you're calling into a WinRT API or a WinRT component that you developed or you got from somebody, that's when you would use a platform string. Otherwise, within your code, absolutely do not use a platform string. On the contrary, use the standard W strings. Some of the characteristics of the string is that, number one thing is it's immutable. You can't actually do operations that change it. Once it's created, that's it. You can take copies of it, which actually would not copy it. It would ref count it, which means creating multiple copies of the string is actually a very fast operation. It also means that if you're doing something with parallelism that involves this string being passed around, it is inherently more parallel because you don't need to make copies. All you need to do is just every time you need to create a thread and pass that to it or have it have access to it, all you need to get is just increment the ref count. So that's one of the valuable things about the platform string. But it's really a very thin layer on top of the WinRT string itself. So it doesn't have a lot of functions. So one of the things that we explicitly decided, for example, we're not going to give you operations to do string builder equivalent things, concatenate strings and replace some of the part of a string with something else, find and match and do all of these things. If you want these operations, go down to the W strings again and use those. And what we really made sure is possible is that the platform string and the standard strings work together very, very well. And that's what I'm going to be showing you. So these are sort of some code examples of what that looks like. On the one hand, you have just initializing a string from a string letter. Notice that you no longer need to say that it's a long string, it's a wide string. You don't need the L prefix with platform strings, mainly because platform strings are only wide. So we'll just save you the extra character. You can use it if you really want to. So line 3 and line 4, we're using it, but you don't have to. You can create W strings. You can construct a platform string from a W string. You can do vice versa. So you can take the W string out of a platform string and create a W string from it. Actually, one thing to note is that this is actually a copy. So the platform string does not have a W string under it. So whenever you're assigning from, for example, on line 2 up there, when it says string 1 arrow data, that creates a full string copy. Okay? And W string now gets assigned from that. You can do the standard comparison operations. So it's basically a very, very thin string. It is not meant to be completely functional for you to live with it as your string type. It's only meant for you to assign stuff into it or take stuff out of it when you're going across a boundary. Okay? So what do you need to be aware of when you're using the string? Well, the first thing you need to realize is the L. I mentioned earlier that the L prefix is no longer needed. One thing to understand about that, and that's something that threw off quite a number of people, is that it's just merely compiler syntactic sugar. It's done completely at compile time, and there's no knowledge of this in the application as code is executing. So some of the things that people would do that would throw them off were things like this. Let me go back to Visual Studio. Before I go and type code in Visual Studio, just a little word about what I'm typing here. This is a standard Metro style application, file new, C++, sample, the standard blank application. And what I did there was, in that main page where it loads, I hooked up to the load event and said, go execute this demo code function. So it's basically the equivalent of a poor man's console app for Metro style. And just simple code where I can actually type in my code. Whenever I start the app, this code is going to get executed. So here I have a a string hello world, right? So notice I don't have an L. If I wanted to do a std_w string, I can create one. Notice if I didn't have the L there, it would complain. You see the squiggle? And that's because you're trying to get an unwide string assigned to a wide string, so you have to have the L. You can do auto hello. Okay. You can create a new string. And you can assign it from the W string, right? And that should work. But if you try to do something like this, that would not work, okay? And the reason it would not work is, look at the type of AS. It's a const char star, right? So this is all, this compiler magic is done at the line where it's parsing. So here we can tell, oh, you're assigning it to a W string, to a platform string. We don't need to see the L. Here, you didn't put an L, but there is nothing here that tells us there's going to be a platform string anywhere in the world. So this is a const char star. This is like a char star. You can't assign, basically create a W string from a string, right? You'd have to do your manual or take character by character, use some algorithm to do that. So that's one thing to note about the L is that you can't, you have to use it in the initialization itself if you're going to get rid of that L. And we had quite a bit of questions about this in our people creating applications coming and telling us, hey, why is it sometimes that it asks us for an L, sometimes not? Well, that's why. Another thing to know about, I talked a little bit about string and copying, and if you're taking a platform string and passing it around, and a certain copy is going to happen. The compiler is actually smart about, and Windows Runtime is smart about doing some optimizations on that string, such that we can reduce the amount of allocation that is happening, for example. So one optimization that you can see is if you're taking a string literal and passing it as a parameter to a function that takes a platform string, for example. We don't need to go create one, allocate it on the heap, then as you're passing it, create something, add a reference to it, and do all of that. We can just directly take it and create everything on the stack. So basically, we create what's called a fast pass string. It's just passed directly as a parameter on the stack to save you some memory allocations. I touched on this a bit briefly a minute ago. If you want to do any operations on that string, use a W string. Do not use the platform string. If you take a quick look at what's exposed through string, so as arrow, basically places to get the pointer to the beginning or the end of it. Concat is actually a static method that concatenates two strings. Data gets you the backing character pointer behind it. And that's pretty much it. There's nothing else no more operations that you can do on that string. So if you want anything with that string, you actually go and you say string std w string ws2 equals s arrow data, right? And from there, you can do whatever it is that you want. So for example, you can do ws2.replace, and then we'll replace the first 5 characters with hi instead of hello, right? Well, it's complaining. Of course, it's complaining because it needs a wide string. Right? Okay, so basically, if you want to do operations on it, just copy to a W string and start using a W string. when do you actually use a W string versus a string? I talked a little bit about the boundary, and I want to elaborate a little on that. The first rule of thumb is if you're calling into a WinRT API, you obviously are going to have to use whatever that WinRT API uses, and it's always going to be a platform string. If you're calling into a WinRT component that somebody created, it's always going to be using a platform string. Inside your portable C++ code, or your own engine that is mostly C++, you want to continue to use the standard types, so standard W strings. So those are the two clear ends of the spectrum. In your own internal code where you've already been using W string, use that. Whenever you're talking to WinRT, use platform string. So what's in between? And what's in between is a judgment call. And it depends on how close you are to which boundary. Sometimes you're going to find it more efficient to stay with a platform string for a little bit. For example, if you're calling multiple WinRT methods in succession, or if you're getting a string from somewhere, getting another string from somewhere, and just want to do a concatenation, you can just create a third platform string that's a concatenation of the two, and create that. So what you really want to do is, if you really care about performance in this area, just quickly look at the profiler, see what the data is. It's going to be pretty easy to tell which one is better. But it's very easy on the sides, on each side of the boundary where to use it. In the middle, use W string as much as possible. Use platform string only when you need to retain it for call within WinRT APIs. Yeah, so the question was, how about lifecycle management for that string, like passing it and adding reference to it on the other side, right? So the way to think about it is think about what we have with the shared pointer in C++, for example, right? So you can create, if you create a string in one place, that is going to allocate a string on some heap, and is going to add the ref count to it and make a ref count of 1. You pass it somewhere else, it goes somewhere else, the ref count is incremented and the ref count is 2. You move it to a third person, the ref count is incremented and ref count is 3. If it goes out of scope in any of the other two, that's fine. The ref count will be decremented. The string is not going to go away because the ref count is not 0. When the last person using it goes away, the ref count goes down to 0 and the string is destroyed. Right? So the WinRT, the Windows runtime, is the one that actually takes care of lifetime management for that string for you. Yeah. Do you require anything on these types for the operations of adding reference and releasing to happen automatically? The one thing that is required is that the type has a hat in front of it. The hat syntax is explicitly what says, please treat this type as a type where you're going to add ref and release to it automatically on my behalf. So any type that has a hat, including the string type, is treated that way. Hat actually means two things. Hat means, number one, please, compiler, do the add ref and release for me automatically. And number two, it means, please, compiler, do some magic such that these methods automatically throw. Methods of this type automatically throw. And I'll talk a little bit more about that in a couple of minutes. But it basically is those two things: add ref release and exception. The last thing to be aware of when you're using strings is you actually do not need to convert from a platform string to a W string just to be able to use, for example, an STL algorithm on top of it. We've actually modified, we've built inherent knowledge in STL of the string types such that you can use those string types within STL. So for example, you want to do some regular expression matching. You can do that directly on a platform string. You don't have to move it to a W string, do the operation, then go back. And I'll show you a quick example of that. Yeah, so let's say we have here a string that has hello world, W string. I'll misspell hello here just so that the results are different for the regular expression matching. Let's bound include regex. And there I'm going to do stud wregex. Let's see which string has a double L, right? So I can do okay. And it's going to take the, if I just wanted to do it on the regular string, this is what I do, right? ws.begin, ws.end, and rx, right? And I'll have a bool, say b equals this, right? This is going to allow me to just use it on a regular string, right? So what does it look like? Let's quickly step into it, just see what it looks like. Here we are in the debugger. We have b. If you look at the watch, and there b equals false, because you didn't find a double L in this, right? I can do exactly the same thing if I want to use it on a platform string. So I can do b equals stud regex search. Did I use match? Should have used search. Match should also return false because it's not a strict match. I can just use s arrow begin, s arrow end, and rx. And this should work as well. Here we go. This do b is going to return false because the standard string doesn't have two L's. But if we do this, it will return true because the platform string has two L's, right? So the thing to remember is, feel free to use standard algorithms, STL algorithms with the platform string. That works. You don't have to convert just for that. So I talked about exceptions. Whenever you have a hat type, one of the things that are already implied, one of the two things that are implied is that this type, all the methods in it will actually throw. This is interesting to say because actually WinRT itself, if you look at the Windows runtime, the Windows runtime does not throw. The Windows runtime is all hresult based. It is just something that the language exposes on top of the Windows runtime to make the syntax cleaner. So you don't have to keep checking for hresults all the time. So what happens under the covers is whenever you have a WinRT function and you see its signature and it returns a very nice type, actually the signature of that function as listed in the metadata file in the ABI is going to be there's an hresult that is actually returned and the return type is actually an outparam on that. The compiler does this automatically for you, that it takes this outparam, makes it the return type, and creates it a very nice flowing syntax where you can call a function, get its return type, do dot, and so it would be like foo.bar.jam, and that would all work. Right? But under the covers, what's happening is there are hresults that are actually being thrown. So what's the relationship between the hresults and the exceptions? Basically, there's a platform : exception type. That exception type is the base of all the exception types that are thrown across WinRT boundaries. And there are 12 known exception types in WinRT, and they all inherit from platform : exception. And each one of those exception types maps directly to an hresult value. So this is basically the table that tells you which platform exception type matches to which hresult. It is not gone from COM, continues to exist. But for this, these are the 12 that you need to care about. Okay?
Is there still the ability to call these underlying calls, or you have to use this mechanism with the exception?
Okay. The question was, is there the ability to call these underlying calls, or do you have to use these the higher level? the answer to your question is yes, you can call these underline calls, but you're not going to be using the hat types. There is a way to call into WinRT without using the new language features. It's just a lot more verbose and pretty non-maintainable looking. So you can do that if you really have to. So if you have a very, very good reason you want to stay away completely from exceptions in a part of your code, you can do that if you want to. I didn't hear, somebody said something. The question was, how can you do this? I'm sorry? There was a morning session that, Dion, you covered this in your morning session, but I'll have one answer for you. There's a file called wrl.h in the developer preview. So if you look at that file, it will provide you with what you need to know on calling this. This is not the way that we advertise people use it. I mean, if you look at what is exposed in that file and the methods that you actually need to do, it is not the most user-friendly thing. But we understand that C++ is all about power and performance, so sometimes you actually need to do that. So there is a way to do it. By the way, if anybody wants to ask a question, just feel free to raise your hand or shout. I don't mind being interrupted and ask that question. But I have a blind spot in that area because I can't see you. So if you actually have to have a question, you might want to stand up and do this or throw something at the podium, not at me. Yeah. All right, so exceptions. So for exceptions, this is sort of simply how it's going to work. If you look at lines 5 to 7, all of them throw. Line 5 explicitly throws. Line 6 and line 7 can throw. So when you're trying to get the picture library can throw access denied exception. If you're trying to do pix arrow get file sync, that might throw if pix was null, right? So if you want to catch these exceptions, it's just like you do in normal C++. You can also do catch exception E only without neither failure exception or any of that, and that's the equivalent of catch ... It's going to catch all WinRT exceptions. Yes. So you're talking about exception propagation across threads, yes. And you're saying, do these exceptions propagate across threads as well? Yes. These exceptions propagate across module boundaries. I'm not sure, Dion, if exception propagation actually applies to this or not. I'll have to check and let you know. So just follow up with me after the session. I'll find out for you. Thank you. Right, so this is basically what's happening across modules. Think about the red and the green as two different modules, and they call each other. On the one side, you're trying to call the function, the function apple, and that throws a failure exception. So what gets thrown across the wire, across the module boundary, is actually an H result of efail that goes on the other side. Somebody reads it and does something with it and throws again the failure exception such that you can catch a failure exception on the other side. Similarly, with the other call, if you're not explicitly throwing, but some operation ends up with a throw, for example, you try to do something on an out-of-bounds operation, that will throw out of bounds, and you can catch it on the other side. But what's really happening under the cover is an E bounds H result is passed. Yes?
All right, what about custom application-specific exceptions? Do they have to be F-types, or can they?
Great question. So the question was, what about application-specific exceptions? Great segue into my next slide. Things to know about when you're using exceptions. There is a way to throw custom exceptions. Thanks for asking your question. So you cannot create a custom exception. So you cannot go and inherit from, and this was a very common question. People would ask, hey, can I go create my, very special exception that inherits from exception, platform : exception. No, you cannot. You cannot. This is not a facility that's currently provided. But if you want to be able to do something equivalent to throwing custom exceptions, remember that exceptions are pretty much all H results. You can create your own H result and pass it across. And the way to use that is by using an exception type called COM_EXCEPTION. And I'll show you how to use it. It's actually quite simple. Let's clean this up. So I'll just do a quick try-catch block. So this will catch any WinRT exception. If something happens in here, whatever you throw in here, throw a ref, new, any kind of WinRT exception, it will be caught by catch exception. So one thing you can throw is throw com exception. And then when you're thrown com exception, you'll provide it an H result. So you can go and say, 0x, I like coffee. Okay. When you catch it here, you can do this. H result, HR equals E arrow, H result. And this can happen across modules as well. I'm here just showing it in the same method, but this is the same across modules. You can go throw a com exception somewhere and catch a com exception in another module, and just you check on the H result.
Just an additional question. Can I also throw traditional non-ref types like, traditional C++ with that same type of?
The question was, can I throw C++ exceptions, and then will they translate on the other side? You can throw C++ exceptions. They will go to the other side, but they will not go as a C++ exception. They will translate as an eFail. Good question. Did I see another hand go somewhere? Yes?
Was there any consideration for allowing custom exception translations?
Was there any consideration for allowing custom exception translations? Can you elaborate?
So that we could translate our own custom exception objects into either H results of our own picking or into an alternate type other than H result, and then provide the layer on the other side to translate back.
There is not a built-in facility for that. You can sort of simulate that by your own, catching your own stuff and then rethrowing and things like that. But there's not a facility for you to do this out of the box. But you can accomplish what you want. All right? So this is basically how you just do the equivalent of a custom exception. It's a poor man's custom exception, but that's how you can get it done. The other thing to notice is, sometimes you want to get a string out of that exception that was thrown, and you'll see toString functions, and some people are asking, what's the difference between toString and message? The interesting thing is for all 12 types now, they return exactly the same thing, but the intention in the spec is that they're actually different. So you can expect them to change going forward. ToString is expected for debugging. There's a string that makes sense for you while debugging, whereas .message is something that is more user-facing. Not user-facing as in please go put the exception in a dialog and let the user read that. Don't do that. But if you want the for example, to create a log file, absolutely that's the one you put in a log file. So if you want to dump an exception in a log file, use .message. Stack trace. ToString does not give a stack trace. ToString just has a message. But that's the current implementation. Do you think it'll be valuable if it has a stack trace? That's good feedback. Thank you. This is sort of another gotcha that some people fall into, which is, we just said that H results and exceptions are one. eFail is failure exception. Well, they are almost identical, but they're not exactly identical. So one of the things that, common gotchas is here, you're going to throw failure exception, okay? And you have somewhere else that can also throw a custom com exception. So what you do here is you do I'm going to catch com exception. And you would expect that, let's say, if bool, if b, throw ref new, else throw ref new com exception, my favorite coffee exception. Okay? I'm sorry, I'm just nitpicky on this. Okay, and let's have a bool here. Okay, so you think that because you're, you may be throwing a COM exception or failure exception, instead of doing a catch failure exception and catch COM exception, I can just do catch COM exception, and this should catch everything. And in there, I will do a switch statement. And then you can say, if it's COM exception, if it's eFail, do this, and if it's coffee, do that. Let's see if that's going to work. B is true, so it should actually go here. Sorry. Did I press yes? Yes. Yes. By the way, don't worry about all the linker interesting things that you're going to see throughout the talk. These are work in progress errors. Don't worry about them. Okay, so let's step through that. And you're going to throw. And it continues. It doesn't catch, right? So what you really want to catch here is you want to catch failure exception. That way you can actually catch it. So that's the one thing to be aware of, is that they don't exactly translate. You have to, let me just walk through it. Here you go. Now we'll actually catch it. So the one thing to be aware of is when you're catching, you catch the most specific type first. So if it's one of those 12 things, you have to catch one of those 12 things. And then you can catch COM exception. What happens if you want to, if you have an H result and you want to throw from that H result? So you called into some COM API, and that returns an H result. You don't know exactly what's inside. It may be an eFail, or it may be one of your custom things. And you want to just throw that. How do you do it? You can create a switch statement that says, if it's eFail, throw this. If it's this, throw that. If it's this, throw that. And finally, if it's none of these, throw a COM exception. But that would be too long. So we actually went and created that nice quick check for you. And we created, if you read that last line here, it says, __ CLI _ winner teeth throw error. This is also some sort of the guts of what we have here, but I'm exposing it to you because you may actually need it. This will actually go out and expand into the switch statement, and will actually throw the right thing. So if you here, if we're throwing a COM exception of eFail, okay, and you're catching failure exception, right? We said this was not going to be caught, but if instead you don't throw this and you do __ CLI _ winner t throw error of eFail, then that will actually catch it, because that will throw a failure exception. Let's step through it. And you can catch a failure exception. So this is the one that if you're already calling into COM and want to just forward that H result as an exception, that's how you do it. Stop debugging. Go back. Somebody had already asked about this. What about C++ exceptions? They propagate as eFail. All right. We all love STL containers. Who loves STL containers? Who uses STL containers? More than half. Okay. STL containers, iteration patterns, algorithms, very useful things for us C++ developers. So when we created WinRT types, several of the APIs wanted to, for example, take a vector or take a map. So we went and created some types that basically match to these. So what we went and created was the following family. This is a little family of what we call the WinRT collections. And that family has basically two siblings called vector and vector view, and two more called map and map view. You can think of vector and map small families as analogous in a lot of ways. We know what vectors are and maps are. A vector is basically a flat list of things, and a map has a key value pair. So what's the difference between a vector view and a vector, or a map view and a map? You can think of the view as a snapshot on the vector. Just the vector as it is now, take a copy of that, or actually it doesn't take a copy, but take a view on that and keep that for me all the time so I can actually use it. So I can iterate over it, for example. Whereas a vector is a completely modifiable thing. You can add stuff to the vector or take stuff away from it. Similarly for the map. A map can be changed, but a map view is just a view on top of that instance of the map.
Question? The vector is also referenced by someone else, and they change it. Does the view change? Is the view always immutable, or is it just a read-only reference to a mutable one?
That's a great question. So the question was, is the view always immutable, or if somebody changes that vector, does the vector view now change? If you can just hold on to that question for another 3 minutes, and then I'll ask you again if I answered your question. The short answer is it'll become invalid. So this is what vectors and maps are actually built on top of. The sort of lighter colored ones are what's exposed in WinRT as in the shape of interfaces. So it exposes an I vector view, and what's called an I observable vector. That's one of the nice features about the platform vector and the platform map, is that they have observable behavior, which means you can actually get a notification when that vector changes. So you can subscribe and say, when vector changed, please let me know. And you would give it a delegate, and then that delegate would actually get called when the vector changes. That is a good thing. It's a very useful thing to use, but it's also expensive. So that's one thing that, in the considerations when we talk about it, that's going to be an important factor here. One thing to also realize is that platform vector and platform map and the views are all basically implemented on top of STL containers. So platform vector actually contains a std vector. A platform map actually contains a std map as its own implementation. This is quickly how, this is what the code looks like if you want to use a vector. Notice here, this is sort of the top part and the bottom part. They're supposed to be different modules. On the top part, there's a producer, and it has a vector. It puts stuff in that vector. And then at the end, it is going to return a platform vector view out of that vector. And a copy operation here is supposed to happen. But notice that I use std_move. std_move uses our value references such that it says, hey, you know what? I actually know that this platform, the std vector v that I created on line 8, I'm never going to need to use beyond line 12. So please do some magic for me and don't copy stuff. Just reuse your own internal implementation of vector and make it that one that was in line 12, in line 8. So it sort of saves that copy. So you can use our value references, which is a feature of C++11, to save some of the copying when possible, when you know that you're not going to use it after that. You could alternatively just remove the std_move and do a new platform view of v, but that will create a copy. And then on the other side, you're getting that platform view from the producer, and you're iterating over it using a standard for each. So a couple of things to know about collections. Number one is you can absolutely mix and match the STL containers with the WinRT collections. They know how to talk to each other. You know how to, so there's a way to create one from the other. The platform one actually uses the STL one as its own backing. So you can continue to mix and match them as appropriate. What's appropriate is very similar to the discussion we had for string. So at the boundary, you absolutely want to be using the platform type. Within your code, you absolutely want to be using the standard containers. Actually, the main reason you absolutely in your code want to be using the standard containers is that they're almost always faster because the platform ones are built on top of them. So unless they do absolutely zero work, they're going to be faster. So you always want to use the STL containers. Just when you're exposing it across the boundary, that's when you go create one of those platform vectors. Let me show you quickly what the code could look like. Here we can have a platform vector of strings. Okay, and I can also have a std vector of a std w string. Okay, I can also do this. Okay, so standard vectors know how to take platform types. That's also okay. They can take reference types. You can add something to the vector. And it's sort of a similar hi. You can add to the standard vector. And notice that this one has to take a wide string because it's a standard W string. Right? You can also do this. And this one will take a platform string, right? That also works. You can copy from one vector to the other using the syntax I showed you. We talked about having the STL containers of a hat type. Most importantly is you can use, you can, for example, iterate over a platform vector, right? So if I have something like, here's a platform vector, I don't have to copy it into a standard vector to move over it. So let's say I have a Windows, : UI, XAML, item, or controls, item collection, items. This is faster. Okay. If I wanted to take the members of that vector and put them in the items collection, I can do that. Standard for each of begin the arrow get view end of the arrow get view comma, right? And then I can have a lambda that does whatever I want there, right? Which would be, or you can take a string hat. Yes? Can auto be used for platform types? Yes, auto can be used for platform types. Yes?
I'm assuming that there's an exception to the comment you can use them in emulators if you use the string hat on a modifying algorithm in STL it won't work. Correct?
You can use them in iterators only if you use a string hat.
No, if you use an STL algorithm that modifies a collection,
Yes?
you cannot use the string hat as the
Yes.
right? With a regular string, so you can modify, erase elements, whatever on the string.
Yes.
But if you use a string cat here in one modifying algorithm, it would not work.
It will depend. Yeah, it will depend on what you're doing. You're right. Correct. All right, and then you can iterate over that string, and that would work too. One last thing is vector versus I-vector. Basically, a vector implements an I-vector. You always, whenever you can, use a vector, not an I-vector. I-vector is only across the boundary if something actually takes an I-vector. But internally, when you have a vector and you for example, call append, the compiler can know that, hey, this is actually still used within the module. You're not doing something fancy. I don't have to go cross-module for this. So I can just directly go and do a vtable call and go access the stuff that uses the underlying implementation directly and not have to go through WinRT for that. So almost always, using a vector is faster than having the interface itself and calling stuff through the interface, because that is always going through the Windows runtime and back. Now the question that was asked on the back on the vector views. What exactly is a vector view? A vector view is, I mentioned that it was a snapshot, but it's actually a view on the current values in the vector. So for example, if a vector has 3 elements, 1, 2, 3, and then you take a vector view, the minute you add a 4th, that view is invalid. So if you try to do view.getAt, it will return, it will actually throw. It will not work. So views are only valid for as long as the vector has not changed. It doesn't go and create a copy behind the covers such that it maintains the same values, and it doesn't change the values underlying it. So for example, if you do view.getAt the second member, it will always be the same thing. You guarantee that it either always returns the same thing or it will throw. So that's sort of the contract. So does that answer your question? Thanks. Iterations over collections are virtual calls. So there is something called getMany that allows you to go and get multiple members at the same, multiple values at the same time. So you can use that if you want to do it faster. Also, sometimes you want to expose your own I-vector. And if you want to do that, whenever possible, just use the platform vector as an underlying implementation, because we did everything that actually needs to be done to get the observable behavior right, to get the view mapping right, to get all of that. And then just whenever somebody asks you for your I-vector, then you go get the I-vector from the platform vector that you used as your underlying implementation. Right? Last thing I'll talk about is the async pattern. Yes?
You mentioned in passing that observable collections are expensive, or the observable part of the behavior.
Yes.
One of, for UI type applications, one of the common patterns is to take an observable collection and bind it to a part of the user interface so that when the collection changes, the UI refreshes itself.
Yes.
So in case of, say, a C++ and XAML application, are you suggesting an alternative pattern and not to use observable collections, or is it still a valid pattern?
So whenever you're calling into WinRT and something that actually expects, for example, an I-vector or I-observable vector for the binding, you're going to have to use that. You'll just need to be aware that it's an expensive operation. So if you would rather not bind it and do some sort of manual, like you handle some certain message and then go populate stuff then, you just need to be aware that that happens. You're not going to be able to get around it if something actually needs an I-observable vector, right? All right, so async. First of all, why is async important? Why am I talking to you about async? The main reason is, well, number one, the common pattern in WinRT now is async API. So if you want to do a create file, there's not a create file. There's a create file async. So you kind of have to use it. So it is important for that reason. But why do you have to use it? Why did we actually go create why did we make APIs async? The main thing is blocking calls are the main reason, together with, of course, the locks, that you get donuts on your machine. Whenever if you can think of your favorite application that shows up donuts, and I can think of a couple of them that we created, then one of the good reasons for that is one of the primary reasons for that is a blocking call on something. And really, we want people to start thinking about using async a lot more often. If you're going to go read something from a file, you know what? It may be a network file, so it's actually probably a good idea that you open that file async and that you read the files async, you read the data async. So that's the main reason why we're introducing async as a primary thing in the Windows runtime. So what is the basic pattern to consume an async API? Basically, you're going to create some operation. That's line 4 up there. So operation being a WinRT operation. And then in line 7, you are getting the member that is called completed and creating an async operation completion handler and assigning it to that. How do you create one of those async operation completion handlers? You basically get a lambda and you create it out of that lambda. So what happens is whenever the operation is completed, the body of that lambda is going to get executed, and the parameter, the one parameter in that lambda is actually the operation results, the return value of the original operation in line 4. And then in line 14, you start that operation. So the code execution goes like this, and I saw a couple more questions here. Code execution goes like this. Line 4 executes, line 7 executes, line 14 executes, and then eventually you're going to go back to line 10. Question in the back. I'm sorry? There is absolutely supposed to be a paren and a semicolon. Good catch. Thank you.
What happens if there is an exception in the operation? What happens if it translated into the lambda? Does it come into the lambda?
It's,
an exception?
if the lambda throws an exception,
No. If the operation that
yes.
that the lambda is waiting for, right, throws, where does it go?
Yeah, so for example, you're saying if operation itself throws, where do I catch that, right? Where do I catch that? The return value for this is going to be some sort of failure. Where you catch it, I'm actually not sure about that. Let's follow in this offline. Yeah. I'm not sure about catching it there. So let's talk about it offline when we're done. All right, so this is what it looks like to actually use it in one of the WinRT APIs that we have. But this is really what it's going to start looking like once you have 5 async operations in a row. This is what the code starts looking like, more like a staircase. So it is not the prettiest thing to use. So that's one of the reasons why I'm going to talk to you about the following, which is how you can actually get async code that looks a little bit easier. So some people on our team went and worked and said, hey, you know what? We have this thing called the parallel patterns library. Who's familiar with it? A few people. So a parallel patterns library provides a higher level abstraction on top of things like threads. So you have tasks and continuations, and that's how you deal with threading at a higher level. And we wanted to sort of hook the parallel patterns library such that you can do async calls with it. We created a sample that you can go download from this link. But basically, with this sample, the pattern looks more like this. It's more like promises that you saw with JavaScript, for example. You have an operation, you create a task for that operation, and then you create a continuation, t.then, and that, pass a lambda to that. There's a hot start, so whenever, at line 5, when you created the task, it started the operation for you. It saved the result if it has actually completed before you did the continuation, and then the continuation is going to have the result. So you don't actually need to go explicitly call it. So with that, the more complex example that I showed you now looks something more manageable like that. Continuation after continuation after continuation. Okay. Super, great. Actually, on this specific topic, we have a usability study for how to use async with C++, and this is one of sort of the alternatives that we were proposing. So if you're interested in this and want to provide feedback on it, I think it's in the in the Hilton 4th floor room in the La Jolla room. So if you go there, they're available today and tomorrow. Just go and chat with our usability team more about it. It's good to hear that feedback. Thank you. Does handling the asynchronous returns work right if your application is suspended? Yes. And last thing I was going to talk about is Win32. And the main thing that you need to be aware of here is that not all Win32 is available to you. There's a subset of Win32 that's available. So if you have existing code that uses Win32, you're going to want to see which APIs are valid and which APIs are not. And those that are not, there are replacement APIs for them that you would need to use. And that's pretty much it for our talk today. So if you have further questions, we can spend a couple more minutes here, and I'll also be available at the booth downstairs for more questions if you have. Thank you.